Alright, real quick, calendar. I think everything I said is everything we just did, right? The only difference is Thursday, part 1 of the test, formulas. Remember, is that going to take all class?
No, that's what we study after.
Does that sound good? Alright, that's what the sub's going to get as well. And then otherwise, unless I say something different through the sub, unless he says something differently, you guys are putting your notes and your spirals on the front table and letting go of them for the 3-day weekend. Cool? But wait, should you do that on Thursday or Friday? Do that on Friday, not on Thursday, because you need to study for Friday on Thursday, yeah? Okay. Calendar is ready to go. Let's go ahead and get back to our notes. You guys ready? Me too. Question, what did you have ready to plug in? Oh, wait. Remember how I said today we don't have time to go writing down all those formulas? We're just going to see if we can use them. Then I'm going to help you narrow down which ones to memorize for the test on Thursday, for the formulas, and everything else you just get to use a sheet anyway. Cool? Okay. So I'm not going to spend time writing down formulas. Hopefully you have your reference sheet. If not, you better make one because you better be studying. Are we all tracking?
Tracking.
I'm getting set. Ish. I made a new system. Okay. What? Go team. What do you have? Well, first of all, where did this formula come from?
Wait, hold on.
There's a 2 with the U, which means it's a double angle. There you go.
Oh, that.
Yeah, that one. Double angle formula. Oh, yeah. Okay, double angle formula says sine 2u is 2 sine u cosine u. Uh-oh. When we write down formulas on Thursday, are we going to put in the u's or the x's or the whatever is there? Thetas? Yes. Otherwise, it's just sin, and we don't want to allow that. I mean, it's inevitable. That's why we need grace, and that's how we love the Lord more. But you guys know what I mean. Okay, in math, no multiplying sin. Okay, so, coming back, what can we plug in right away?
We can plug in the sine of u right away, Miss E.
So where does the sine go if I'm plugging in? Where's the sine go if I'm plugging in? Is he gone? Yeah, he's gone. And who is in his place? The number. Sine is gone. I'm plugging in. Negative 3/5 is in his place. Those of you that think I usually go too fast, maybe because I do, I've been slowed it down. Cosine. Wait a minute. It's not there. What do I? Oh, I draw a triangle. Nope. Why not there? Yeah, where are they telling me? What quadrant? Quadrant 4, 3 pi over 2 to 2 pi. We're not going to be super precise for obvious reasons, but also ain't nobody got time for that. So, we got negative 3 over 5. How do I know that? Because sine is equal to?
Opposite over hypotenuse.
Yeah, so who's missing?
4.
And are we going to make him positive or negative?
Positive.
Because, first of all, I'm going to the right. That's positive, right? And second of all students take calculus. Cosine is positive. So who is my cosine?
4 over 5.
Oh my goodness, kiddos, it's arithmetic.
Wait, why is 5?
Wow.
Why is 5?
The hypotenuse is always positive. Think the radius of a circle is always positive.
Okay.
If that helps.
Yeah.
Now what? How do we multiply fractions? All the tops over all the bottoms. Hence, I get. Mental mathers, you did the top. Haha, I did the bottom. Negative 24. Careful.
Oh, times 2. Whoa, mine.
2 times 3 is 6, and 6 times 4 is 24 with a negative. Dun 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 dun.
Dun dun.
Not too bad, right?
Not too shabby.
And kiddos, hold on. Are we good? You crazies over there? Once we get to cosine 2u, all we got to do is say whatever. We already have the triangle. Plug it in, plug it in. How? What's this whole cosine squared of u thing bobber doing? How do I plug into that? Don't get tricked by the trig notation. Cosine squared means take the cosine and do what to him? Yeah, that's all it is. It's not harder than it looks. And we get to get rid of that sine and get rid of that cosine by just looking at our triangle. taking what we already know to be sine, know to be cosine. Does that make sense? Uh-oh, that's not cosine. Who is that?
Is the 1 minus 2 sine squared of u?
Should end up being the exact same thing. All three of those variations for the double angle of cosine should get the exact same formula every time. Sorry, not same formula. Same answer every time. Hold on, are we okay? The squared means take the cosine, square them. Minus, the squared means take the sine and square them. How do I square fractions? Come on, cool kids, arithmetic. 4/5 times 4/5, yeah? 16 over? It's a rainy day. We're on top of things, yeah? Minus, square it. Good. 7 over 25. Dun, 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 dun.
Done.
How we doing?
Very good.
Yeah, right? Just gotta be careful. It's a little funny. Watch out for the arithmetic. No math mistakes.
I gotta take some of it.
Alright, cool kids. Oh no! Who's tangent?
Who is she? She's sine.
She's sine over cosine to make it easier. You have a triangle. Opposite over adjacent. What would it be? Look at your triangle.
3 over 4.
Yeah, you got it. I don't know. I like the triangles just because you don't have to think about all those properties. You know what I mean? You can. Sean, you could have done sine over cosine. Would have totally worked. The over 5s would have canceled. You would have gotten negative 3 over 4. Either way. Make sure everything's legal. Come on, cool kids. Hold on. Some of you, your Achilles heel is just the math, not even the trig or the pre-calc. Right? On top, it's 2 over 1. Cool? Can I do negative 6 over 4? You guys beat me then? All over 1 minus 9 over 16. Complex fraction. There are many ways to do it. We've talked about all of them. We could take this little 1 and say, hey, 16 over 16, please, and then keep going. Or we could do my trick. What's my trick? Take the greatest, take the common denominator, which would be 16, and multiply top and bottom by that 16. Let's say, ooh, let's get rid of all those nasty fractions, please. But don't forget, this is an entire denominator. He's a quantity I have to distribute. Boop, boop. What do I get up top? 4 and 16?
24.
Good, negative 24.
Over 7.
Careful. You're right. Making sure everyone's tracking. You got to distribute that 16. 16 times 1? Is that okay? Minus, what happens when you bring him over here? What happens to the 16? Who's left? Nice. Hence why some people were already starting to say 7. But if we didn't distribute, would we be at this correct answer? Nope, we'd be having some issues right about now. Dun, 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 dun.
You like fighting with the muscle?
I'll be happy when they hook up my iPad so I can read. I would be able to do it, but I need passwords that I have. Yay. Okay, so kiddos, did we practice the double angle formulas from yesterday? Yes. We practiced with not only, let's see, didn't we solve an equation? Okay, we solved an equation for so many angles using the unit circle. And we solved with triangles. Let's see what else we're going to practice today. But first of all, oh no, more formulas. Blah. But if you have these already written down, perfect. You're going to be able to use them. If you don't already have them written down, if I were you, I would skip a 1, a 2, a 3 lines, and let's keep going. It's more important to use them today, right? But quick heads up, do I have this box highlighted? Uh-oh. He might be more important than some of the later non-highlighted ones as far as studying for test part 1. But write down the example. you want to skip lines for the formulas, go ahead, or maybe you can rush and get them in, but I'm starting on the example. They are called the power reducing formulas. Por qué, por quoi? How come? Because the sine is squared on the left and cosine is, even though it has a 2, it's to the first power. Cosine is squared on the left, even though on the right it has a 2u, a double angle. It's still cosine to the first. It is reducing the powers from squareds to singles of the powers of the trig. This is especially useful once you get to calculus, and there are these things called integrals that are hard to find, and we don't like the squares if we can have the singles. The singles are way easier. So that's about all I can do to explain to you as to why it's useful. How on earth did I change cosine to the fourth to be cosine squared, cosine squared? I split it up. Why did I split it up? Because there's no formula for cosine to the fourth. But is there formulas? Is there a formula for cosine squared?
Yeah.
So what am I doing? Look, I'm trying to break down the powers. It has a 4 right now. I need it to end with a first power. Struggle. So this isn't good enough? No. But I do have formulas to plug in from up above. And that's what I'm going to do. 1 plus cosine of 2u. All over. And technically, can I put a little square just to kind of get the idea? There's 2 of them. Is that cool? And you should save in time. Now guys, this cosine does have a 1, but what's the struggle about the power out here showing? It's a squared. Doesn't cut it. I need to get all the squares, all the extra powers away from the cosine. Not just away, but reduced down using these formulas. So the struggle is, you know what? It's not far enough. It's closer. Not far enough. So what am I doing right now when I'm starting to write 1 plus 2 cosine of 2u plus cosine squared of 2u. What did I just do? Yeah, I foiled. Why? Because it's squared. Why is there a 4 on the bottom? Because it's squared, right? I foiled the top. First, outer, inner end up combining to be 2 cosine 2u. Why wasn't I done? There was this hiding cosine squared. Not good enough. I need to go all the way down. Now, to make our lives a little bit easier, ready? To make our lives a little bit easier. Actually, to make my life a little bit easier, I'm just going to keep going and I'm not going to simplify. We could technically divide everything by 4 right now and it might look a little nicer. But for me to not have to write an extra step, I'm going to go ahead and just kind of be rewriting. Why? The 1's cool. He's not cosine to a higher power. The cosine 2u, the 2 cosine 2u, he's cool. It's cosine to the first power. Who's not cool? What on earth do I do with him? There's a formula for that. Yep, look up above. Power reducing formula. I can change the squared to be, wait, does anybody see something that's different between, struggle. So actually, I'm going to have to go ahead and change the formula just a little bit. Because the formula says, give me a cosine of the normal u squared, and I will give you 1 plus cosine double that angle over 2. But what am I starting with in this one, guys? What angle was there to begin with? 2u, yeah, so I have to go ahead and say, I gotta double that. So it's going to be 1 plus cosine of 4u. Why? The formula says take whatever is inside the cosine and double it. So what was in there to begin with my squared? 2u. I doubled it. And then all of that is over 4.
I still think the cosine to the 4th of x is prettier.
To the 4th?
Yeah.
Well, it's
Look at all
easier.
this.
But I promise you, in calculus, in a thing called an integral, this one is torture, and this one is, oh, whew, so much easier. Well, not the way it's written. Hold on. Everybody thinks this little over 2 is gross, right?
Yeah.
Okay, how do we get rid of that little over 2? What's my
Make
trick?
it over 8.
Yeah, multiply. But careful, you can't just put over 8 because these guys have to be dealt with too, right? We have to distribute everybody. Times 2, times 2, times 2. So what do we end up getting? On the bottom, 2 times 4 is 8, no big dealio. On top, 2 times 1, 2. The next term, 2 times 2 cosine 2u, 4 cosine 2u. And the last term, oh thank goodness, this makes it look a lot better. Because the 2 over 2 cancels, right? And we end up with 1 plus cosine 4u. Now if I was writing faster, I would make you guys go one more step. And what's that one more step I would make you do? No, not that hard. Can the 2 and the 1 combine to be a 3? I would combine my terms, but right now I'm being lazy, and I'm just going to box it and say done. But if you see the 2 and 1, you technically should combine my terms. The final answer would be 3 plus 3 plus 4 cosine 2u plus cosine 4u. Dun 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 dun. We're losing some of our enthusiasm. Is it because we're focused? Oh, okay.
It's a rainy day. We're all
Now, hold on. Wait. Whew, we're not going to do this one. But what would you have to do to reduce all the way down to the first power? What would you have to do?
Sin of 2x times sin of 2x times sin of 2x times sin of 2x.
You could, but the problem is that's still sine to the 4th. What's the only way to actually break it down so that there is no repeated multiplication still shown? You have to use the formula. Now, I'm not going to totally use the formula. I'm not going to finish this whole shebang, but what I am going to show is, does it make sense that sine to the 4th is sine squared times sine squared? And then if you look at your power reducing formulas, hopefully you have them ready to go today. It'd be 1 minus cosine of double whatever's there. And who's in there, guys? 2x. So the formula says 2u, which means take whatever's in there and double it. To make it easier, we'll just say 2x doubled is 4x. And then there's 2 of those. I'd square it. You guys see how we now have to go through and do all the stuff we just did? Now the process is very similar, but this is how we reduce the powers of a trig that's raised to a higher power than 1. Cool? I mean, not cool. It's kind of annoying. But I am promising you, in calculus with integrals, we'd much, much, much rather go through all this work and get to, like we did on the last page, something where cosine was to the first power, cosine was to the first power. It's a possible problem in a calculus application, whereas this one would have been impossible. Okay. Kind of messy. That's how power reducing formulas work. Another set of formulas. Gross. Half angle formulas. Why are they called that? Oh, come on. Look, it takes the angle and it cuts it in half. What angle? I don't know. 30 cut in half. 15. This helps you find sine of 15 degrees, even though it's not in the unit circle? Sine of 210 over 2. This helps you find sine of 105 degrees, even though it's not in the unit circle? Just how does it work? Well, basically, plug it in. But what's weird about the example you guys see down below? Do they tell you use the half angle property in order to? Nah. What do they say? Find it. And you're like, well, stink, 105. He's not in the unit circle. How can I find it? You gotta think about him and say, is he related to anybody special? Yeah. I might have Freudian slipped it a second ago. To say, oh wait, Isn't 105 half of who? Is 210 in the unit circle? Where is 210 in the unit circle? Quadrant 3, 30 degrees past 180. So he's a pi over 6-ish one, and more specifically, 7 pi over 6. Good. He's a pi over 6 one, and more specifically, 7 pi over 6. Long story short, 210. Oh, I got that. 105. Until these formulas. All right, cool kids. What formula am I using if I'm doing sine of? That's a struggle. 1/2 of 210. This guy. I'm not starring him saying he's the only one to memorize. I'm starring him because he's the one I need. Right? Yes, I'll write down the formulas because he didn't have them written earlier. Okay. Sine of u over 2. Who's u? Well, in this context, to get 105, I need 210, right? How do I plug it in? That's new. Plus or minus? Uh-oh, we'll come back to that in a second. Hang in there. Square root, just plug it in. Cosine of? Oh, nope. 1 minus cosine of? Good. Not 105. Remember, he's the guy that we don't know much about. He's not in our unit circle. At least not one of the ones we memorize. Let's look at the formula. I'm trying to find sine of 105. He is half of 210. 210 is my u. 210 is who's coming in. All over 2. Alright, cool kids. Show off. Be amazing. 210, we already talked about him. He's 7 pi over 6. He's a 30 degree in the third quadrant. He's this guy right here. Who is his cosine? Yeah, adjacent. It's going negative. And it's going negative a lot, not negative a little like pi over 3's. So who is that? Square root of 3 over 2, but a negative. I think so. My cheater chart people. Would you have been able to make your cheater chart and then go find a 30 degree and see that cosine is root 3 over 2 and make them a negative? Yes. Right, other unit circle people, that's the y, that's the x value. As you're drawing your unit circle. Now, how messy is this? Ugh. But haven't we kind of been practicing complex fractions this class? How do we get rid of that nasty little 2 that's just chilling in that numerator? Yeah, multiply top and bottom by 2, right?
Is the 2 included in the square root?
Yeah.
Okay.
Sorry, I didn't draw it so good.
My bad.
No, you're good. So still under the square root, we're doing everything under the square root. We can multiply the top by 2, the bottom by 2, just to get rid of that complex fraction. Remember the top, we got to distribute. There are 2 different terms that need that times 2. We'll get plus or minus square root of, people in the back, I'm sorry, here you go. Does that help? What's 2 times 1? 2. Minus a negative will be plus. What happens when the 2 multiplies by the root 3 over 2? Who do I have left? All over 2 times 2? 4. Now we have 2 big things we need to do. One of them is actually a little thing and the other one's a big thing. The first one is we can actually rewrite this, even though it's still going to be messy. We're not going to go any simpler than this because, to be honest, there's not really anything simpler than what you see. There is a square root in a square root, and we're stuck. There is a square root in a square root, and we're stuck. But we can look at that denominator who's in a square root also and say, hey, what's root 4? Okay, so we can do that. That way we don't have the square root in the denominator. But we have this dilemma, and the dilemma is, you see how there's a plus minus, right? So hold on, with that plus minus, does sine usually have two signs attached to it? For one particular answer? Nah, that doesn't make sense. So hold on, we have to go back to the very beginning and say, who are we finding again? Yeah, because sine of 105, who we're using 210, but who's the actual angle that we're dealing with? Yeah, we're dealing with 105. We're dealing with somebody in, more specifically, the second quadrant. He's not very far in the second quadrant, but he's in there. We're dealing with 105, so in order to pick the plus or minus, we got to say, hey, this guy right here, 105, what sign would he have for the sine function? Positive. Dun, 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 dun. Don't put plus or minus. Just make it positive and we're done. Dun, dun. Hence why there's a note up at the top that some of you guys were writing. Watch out for the sign. Choose the plus or minus based on where you're supposed to be. Does that make sense? We're using 210. We're plugging in 210 information, but at the very, very end, to answer this question, we look at the actual angle-ish, figure out what quadrant, and assign the correct sign. Does that make sense? Questions on that? All right. We're just quiet and tired. The air turned off, so we're getting warm and snuggly. Okay. Uh-oh. What about this one? I'm just trying to give you funny stuff you're going to see in homework. Is that okay? I'm just trying to give you as many examples as possible. Did they give us an angle? Stink. What'd they give us? Sides. Ooh, from sides, what can we make? A triangle. All right, what quadrant are we in? Quadrant 4. What's the triangle going to look like? A little baby guy there and a long guy here. How did I know that ish? Turned out a little differently than hoped. Because what's my opposite? What's my hypotenuse? Longer. Does that make sense? Fabulous.
13.
Ooh. Tricky, tricky, tricky. Good catch. Okay, leave the one, so we're going to need him in a second. So who's this guy?
13.
Nice. I have opposite, I have adjacent, little opposite, long adjacent, and then, well, there's just the corresponding hypotenuse. But question, who is this for? For you. And what are they actually having us find? The half. Ah, struggle. Now, guys, we already practiced the signs. That's kind of lame. Let's practice the cosine. I know we were supposed to do all of them, but whatever. Who has time for that? Not us. Okay. Cosine. Who has the formula? Come on, someone amazing who wrote it down. Either cheated today or had it ready earlier. Okay, cosine u over 2 is equal to? Okay. 1 plus cosine. Hey, is this really similar to the sine, just with the plus instead of the minus? So maybe we can use that in studying, like we don't really have to memorize. We just have to know which sign goes with which. Is it cosine u? So why did they give us of u? Because who's going in the formula? U. Right? Alright, cool kids. What do I plug in? Who's cosine of u? If I know that tangent of u is negative 5 over 12, and we made our triangle appropriately, which we now did. Thank you, Ellen, Luca, for catching. What do I plug in?
12 or 13.
Good. Go look at him. Cosine adjacent over hypotenuse, 12 over 13. Is it going to be a nasty complex fraction? Yes. But do we have reason to fear?
No.
No! We got this. Sean, what are we going to do?
Well, we're going to neutralize that.
How?
We're going to use our special skills of the complex fraction and find this time by 2 on
We're going to multiply by somebody, but who?
Oh, really? 13?
Close. There you go. Why 13? He's the little guy who's messing me all up, yeah? But perfect. Multiply top and bottom. Don't forget your parentheses. We end up with, remember, distribute. What's 13 times 1? 13. Plus, what happens when we distribute to the 12/13ths? We already did that one. Let's go to this one.
You're gonna have a square root on the bottom.
We are, it's okay. We're getting ready for calculus. In calculus, we really don't care. We just leave it. So maybe we'll be cool like them today.
Yeah, wait. I just want to be cool like Jordan.
People.
How is that possible?
I don't know. He and Dylan were playing baseball with my wooden pie sign and a nursery ball yesterday. That was pretty stinking cool. Using my desks as bases. Wait a minute! Oh no, we're not done. We can't be done because we have to still choose the. Aww.
Since it's cosine, also secant.
Yeah, we could do that. Do you guys want to make it look prettier? Karina was like, "Isn't that 5 over root 26?" And then if we want to be really cool, Luca was saying, taking away the square root. I guess we could rationalize 5 root 26 over 26. All right, we'll do that. Square root of 25 is 5 over root 26. Doesn't simplify down, so multiply top and bottom by the root. It's called rationalizing, but we still have to choose the sign. So question. Do we have a picture of the u over 2 that we're supposed to be looking at?
Yeah.
Do we?
It's.
No, who was
no,
he?
that's true.
Ah, you gotta be kidding. Wait, hold on. What quadrant is that in?
Or.
Give me somebody, anybody in the 4th quadrant, an angle.
330.
Okay, 330. We need to go past 270. 330 works. Cut it in half. Let's see where that would be. 330 cut in
165.
half is 165. Isn't that the 2nd quadrant?
Yeah, so it's gonna
Okay,
be
hold on. Pick another one. Pick another one. 320. How about that one? Cut that one in half.
379.
No.
No, 359.
350. Oh, that's too hard to cut in half. Do 320.
Because.
What's 320 cut in half?
160.
160. It's still the 2nd quadrant. How about 350? We do that one. 350 cut in half. 175. Still in the 2nd quadrant. Where are all of the half angles of all the 4th quadrant dudes? And the 2nd quadrant. Who am I trying to find with cosine? Oh, I'm trying to find cosine. And cosine in the 2nd quadrant has what sign? Negative. Dun 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 dun.
Done.
We had to like do some exploration on that one. Luca, come on down. Eric, come on down. Something about, I don't know, stuff. Don't worry, they're white, not blue. Or pink. Or what are the bad ones? You're leaving at, 10:45, sorry. From doing nutrition. But you have a note. Yay. Okay.
No.
Oh no! We have more formulas!
But they're not in yellow.
But they're not in yellow. Ooh. Jesse, these ones aren't in yellow, which means don't have to worry about them at all for Thursday. Issa, good news, right? Don't have to worry about these at all for memorizing. Just can you use them? Yeah, but I'll print out a sheet for you for Friday. So you only want them written down if you want to be able to get to them quick for homework. When are you going to use them? When you have a product and you want a sum, or you have a sum and you want a product? Well, sum or difference, technically. Remember, we're not taking time. Hey, use the someone who wrote it down help us out because everybody else is going to be floundering. We have what? Wait. Sine and cosine, are they being multiplied or added? Sine and cosine being multiplied or added? Multiplied, which means they're a product. And they want us to rewrite it as a, pretend that's straight. Sum or difference. I was trying to make it somewhat squiggly, just not that much. Let's go look at all those formulas and figure out which one helps us with a sine of something times a cosine of something. You ready? Who helps us with a sine of something, cosine of something? Nope, a nope, a no. Ah. We're going to use this guy. 1/2 sine of the sum plus sine of the difference. It's not that bad, but good news, we don't have to memorize it. We're just going to plug and chug, right?
Yeah.
Oh, what? It's okay. Hold on. So 1/2 I told you guys, I warned you. Sine of the sum of who? Wait,
Well, that's interesting
the sum of the guys inside.
so we have X and Y.
Ooh, who are the guys inside? This is going to be your U, and this is going to be your V. It's just whoever's inside, however messy it is. So sine of the sum, x plus y plus x minus y. You guys tracking? We're taking the U plus the V via the formula. And then we have sine of the difference. Come on, someone amazing who wrote this down last night. Is this a plus or a minus for a sine cosine? Uh-oh, I heard both. I'm going to go check it. Sine, cosine has a plus. Okay. Sine, cosine has a plus. It's just very bold. All right, so what do we get?
We get sine of 2x.
2x. Right, because the x, 1x plus 1x is 2x. What happens to the y's? Boom, boom.
Oh, 2x.
Uh-oh, we got to distribute our negative, right? Who cancels now? I think the x's. Is that right? Double check me.
Yes.
Yeah.
Okay.
It's y, 2y.
Hey, did we change this to be a sum or difference? Basically. If we want to be super snazzy and say we don't want any multiplication, at least not written, we could move that little 1 half in. Right? If we really want to and say, hey, it's a big old sum now. I don't like mouses.
We're allowed to separate.
Just multiply.
I didn't have the plus in the
Oh, got it. Otherwise, yeah, we'd be in trouble, right? But the plus, we distribute.
Yeah.
You guys are doing awesome. Oh my goodness, are we almost done with this horribly long section?
We're done. No, we're not.
But good news is it highlighted. Woo! All right, just can we use it? Use it to do what? Last example of the day. How?
Right.
Help, kiddos. How? Question: how do we get x by itself? We cry.
Yeah, we
Or
Yeah, we cry. Yes.
Yes, we cried.
or we say, wait a minute.
Good.
Isn't that a difference?
Enough knowledge.
Isn't that a difference?
Enough knowledge.
And can't we use the sum to product formula to say
Yes, we can.
sine minus sine is 2 cosine of? Focus, my ones in the back who are talking a lot. We're trying to finish. We're going to add the 2, divide by 2. Subtract the 2, divide by 2. Why does this help? Oops, wrong way. Can someone keep me honest? Someone has this written down, please. Please. Okay. We have cosine 2x. Oops. All over. Oh, struggle. Double struggle. All over. Who has it for me? Oh, what? You guys fail. 2 cosine. Add it, divide by 2.
I'm saying it.
Okay, 3x plus 1x is 4x. 4x over 2 is 2x. Times sine of, you subtract the 2. 3x minus x is 2x. 2x over 2 is single x. How does this make things better?
What about the
Well, I see we can factor, but can't we also do cosine 2x? Now guys, hold on, I'm going to skip a step. Can we multiply this up? Whoop. Can we multiply this up? Whoop. All of it?
Yeah.
Then can we subtract it over?
Yeah.
Why is this now possible, whereas before we were in some serious trouble?
Because you had it equal 1.
Because now can we take out the cosine 2x?
Can we factor this puppy?
Yeah, we can.
I'm gonna finish this factoring, you guys. You're gonna get out of here tonight. You're gonna work on homework and do the best you can, but you're gonna have those formulas close because you don't have to keep them memorized while doing problems. But you're getting ready for Thursday, so you're memorizing anyway. But the non-highlighted ones in notes. Bye, guys. No, sorry. Ignoring the non-highlighted ones.